Hi everyone, it's Rohan this side from Lebanese Kids Academy, and in this video I'm going to share 8 different doubts that have been sent to me by my students from the Statistics 1 batch, and specifically the questions are coming from the chapter of probability, where let's say if you are clubbing the probability concepts with the permutations and combinations or the distributions. So if you are someone who is struggling with this kind of things, that when you have to combine these two things, or if you are trying to solve some kind of intermediate to hard level of questions regarding this, this particular video will be pretty much helpful to you. So one important thing, just before we start the video, I have recorded this entire video keeping in mind that I am doing it for my students at the academy and not for the general students on YouTube. So you might find certain bits of the solution maybe at the starting of the video and or the ending of the video where it is irrelevant for you. But of course, you can choose to ignore those parts and focus only on the solutions of this particular questions. And apart from that, if you want the PDFs of the unsolved and the solved worksheets, both of them are available in the description of this video. You can get access for the same. And then let's say if you are someone who is struggling with your mathematics, and if you want to improve overall in your mathematics, it could be statistics, mechanics, or the pure mathematics, and you don't know from whom to learn, and if you find my solutions over here interesting or the way that I teach interesting, you can always reach out to me and we can discuss for the same. And yeah, the numbers and everything will be visible on the screen right now. So yeah, let's get started with this video. Hi guys. So it's 4 a.m. in the morning when I'm recording this video. Actually, I just came back home from my work and I'm actually exhausted right now. But this is the best thing, a best way to tell you girls that this is what a discipline is all about. When you have committed something, you make sure that you are showing up, right? So over here, I'll try my best to explain everything in the greatest possible way, just like I would do in the morning classes or in the afternoon classes. But yeah, this is going to be an example that if your intent is clear, no matter whatever is the time, whatever are your feelings, you keep that aside, be disciplined and do your work, then you can go to bed. Okay, of course, sleep is very important. That's not something that you can, you can just gamble upon. You should have good enough sleep. There is no excuses about that. But yeah, I'll have my proper sleep tomorrow. There is no issues. So let's get started with the first question. Bag A contains 4 balls, bag B contains 5 balls, and bag C contains 7 balls. And all of the balls are having some kind of numbers written on it. And one ball is selected at random from each bag. So from bag A, I am selecting one ball. From bag B, I am selecting one ball. And then from bag C, I am selecting one ball. Now there are two events given to us. Event X is such that there are exactly two of the selected balls having the same number. So out of the 3 balls that we'll be selecting, uh, in 2 of these balls, we will have same numbers. So this is called one event. Of course, there could be different numbers also, but we don't care about those kind of events. We are caring about when we pick 3 balls, 2 balls must have the same numbers written on it. And then there is an event Y where the ball is selected from the bag A and it has a number 4 written on it. So now we are not talking about all the balls, we are just talking about the ball that we are selecting from bag A, and it should have 4 number written on it. So there are these two events given to us. In the first part where we are supposed to find out the probability of X. So what is the probability of X? Whenever I'm going to choose the balls, I want to make this kind of a selections such that if I'm just for an example, let's say if I'm choosing bag A and bag B to have same numbers. So I can clearly see that 8 is the number which is same. Okay. So in that case, if I have to create a formula for part A, that what is the probability of X? Okay. In that case, let's say I'm saying that I'll be selecting the same number balls from bag A and bag B, but not C. And then similarly, I'll choose the balls with the same numbers from bag A and C, not B. And lastly, probability of AB is done, AC is done, I guess BC is remaining. BC but not A. Okay, so BC is having same numbers and A does not have it over there. So in this case, what I'm going to do is I am going to write down what is the probability of the ball that I'll be choosing will be having the same numbers from bag A and bag B alone. So in bag A and bag B, if I see the common thing, it is 8. Okay, so what will be the probability of choosing an 8 from bag A and bag B and not 8 from bag C? This is the criteria. So from bag A, the probability is 1 out of 4. From bag B, I'm just going to write a dot for the multiplication symbol. From bag B, it will be 2 out of 5. And now 8 should not be there because we want exactly 2 balls having the same number, not 3. So now from bag C, of course, I'll need to choose 1, 2, 3. So out of 3, sorry, out of 7, I'm going to have 3. Now similarly, I'll repeat this process for A and C. So this is my bag A, this is my bag C. I can see that there are two similar numbers or exact numbers. That is this 2, and then of course there is 8 also. So this will be split into two further probabilities, one for 2 and one for 8. So let's first do for 2 and then we'll do for 8. And for that, I'll create a bracket and I'll say that, or bracket is not really important. So for the probability of 2 from bag A is 1 by 4, from C 1 by 7, and in bag B there is no 2, so we are good. We can select any one number over here. So I can say that 1, 2, 3, 4, 5. So 5 by 5, right? We can choose any number, which is basically 1 only. And now let's talk about 8. So from bag A, the probability is 1 by 4. From bag C, the probability is 1, 2, 3, 4. So 4 by 7. And from bag C, from bag B, we don't want to choose 8. So there are three things that I can choose from the 5 balls. And lastly, BCA. So BC should have the same number. So B and C, clearly over here, 8 is the number which is repetitive or same. So yeah, I can just go ahead and say that from bag B, if I'm selecting 8, it is 2 over 5. That is the probability. From C, 4 over 7. And then from A, I don't want to select this 8. So I am having 3 out of 4. So now if I calculate this, let's see what do we get. If I take out my calci, so on the top it is 1, 2, 3, in the bottom it is 4, 5, 7. And if you can see in the bottom it is always 4, 7, 5, 4, 7, 5, 4, 5, 7. These numbers are common. So I'll just do 1 divided by 4 into 5 into 7 as a common factor. And then for the numerator part, I can just keep on multiplying things. So on the first part it is 6, then it is 5, then 4 times 3 is 12, plus uh, 2 times 4 times 3. 4 twos are 8, 8 threes are 24. Or just because I'm not sure if it's really 24, I am a math teacher, right? Anyway, so this is the answer that I'm going to get, 47 over 140. 47 over 140. So this becomes finally the probability of x, and just doing this you get 5 marks. Isn't it amazing? That is why I love statistics. You just have to do something and you get multiple marks, right? So over here, the thought process was that if you are able to understand the event X, and based on that, how you can utilize the given bags and the numbers written on it. In your case, maybe you are thinking a bit differently. But yes, if you are not thinking in this way, it's definitely worth trying in your way and then try and see if you're able to get this answer or not. So because Madhu had doubt only in the first part, I am doing the first part. For part B, I'll just orally explain how you are supposed to do it. You are supposed to find out probability of X intersecting with Y and determine whether the two events are independent. So for the events to be independent, this should be equal to the individual probabilities multiplication, like this. So probability of X is something that we have already found out. What is the probability of event Y? We want 4 to be selected from bag A. So that is 1 out of 4. So 1 by 4 is the probability over here. And X probability was 47 by 140. So if you multiply this two, it should be equal to probability of X and Y happening together. So now what is the probability of X and Y happening together? So from bag A, you are only picking ball 4 and such that from bag B and C, you are having two exactly same numbers. So of course, 4 is written over here from A. So from bag B and bag C, you can clearly see 8 is the only number which is the common thing, right? So yeah, based on that, you can find out the probability of X and Y just exact in the fashion that we have calculated over here. And you will see either this value will be directly equal to the multiplications of the individual probabilities, or it won't. If it is equal, then they are independent. If they are not equal, then they are not independent. That is the criteria. Okay. So yeah, that is the first question. I am not writing anything about part B because that was not asked as a part of the doubt. But yeah, in case if you're not understanding this as well, let me know in the WhatsApp group. I'll definitely help you out. Moving on to the second question. So Janice, whatever is the name, is playing a computer game. She has to complete level 1 and level 2 to finish the game. So basically there are two different levels, and to finish the game, she needs to complete both the levels. She is allowed at most 2 attempts at any level. So at level 1 there are 2 attempts, and then at level 2 there are 2 attempts. For level 1, the probability that she completes it at the first attempt is 0.6. So in level 1, if she is able to complete in the first attempt, the probability is 0.6. If she fails at her first attempt, the probability that she completes in the second attempt is 0.3. So of course, you should be aware about the tree diagram in this case. So I'll just draw a quick tree diagram for level 1. So let's say this is the branches for the first level, and if she is able to complete it in the first go, it is 0.6. So of course she is going to fail will be 0.4. Okay, so maybe let's call this as C for the complete and F for the failure. And then they had mentioned that if she fails at her first attempt, the probability after that she can complete the level 1 or she can again fail. So the complete probability is 0.3. So of course the failing probability is 0.7. So this is for level 1 that I have made just by reading the first bullet point. Now, if Janice completes level 1, she immediately moves on to the level 2. And for level 2, the probability that the Janice completes it at the first attempt is 0.4. Of course, it is more tough than the level 1, so the probability of completion has been decreased. And if she fails at her first attempt, the probability that she completes it at her second go is 0.2. So a very similar diagram I can draw for my level 2. So complete, failure, and if she is going to have a failure, she can have another chance. And if I go ahead and try to write down the probabilities, so if she completes at 0.4 the failing is 0.6, and the second time if she is going to complete it is 0.2, so this will be 0.8. Okay, so this is for level 2, and the purple one is for level 1. In part A, we are supposed to show the probability that Janice moves to the level 2 is 0.72. So for Janice to move to level 2, she should complete the level 1. So what are the ways through which Janice can complete level 1? It is either 0.6 or 0.4 into 0.3, right? In the tree diagram, what do? We start from this particular point and then move in the path through the branches that is going to let, get us through the end goal. In this case, it is the completion. Only after completing the level 1, she will move on to level 2. So the first path is this, and the second path is this for the completion of level 1. And hopefully we get the value of 0.72. It's only one mark, of course it has to be very easy. So I can say that the probability of level 1 completion is equal to 0.6, or first it was a failure but then it is a success in level 1. And if I take out my calci and complete this, zero point 0.6 plus 0.4 into 0.3, it gives me 0.72. So I hope Madhu you are able to understand this, and along with I hope other two are also able to understand this concept. So yeah, this was the doubt by Madhu. The second part wasn't the doubt, but yeah, again I'll just go through how you are supposed to do this. And I'll do one thing by the end of this video. I'll also complete the remaining parts which weren't the doubts as such, but still for the completion of this worksheet, I'll just write down the working and send it to you, the complete worksheet, okay? But for now, just to save our time, because this was not the main doubt, I'll still go over it. So find the probability that Janice finishes the game. So when will Janice finish the game? She will finish the game once she completes level 1 and level 2 both. So probability of completing level 1 is already given to us as 0.72. Now after this, what's going to happen? She is going to continue to level 2. Now in level 2, what can happen? Either she can complete in the first attempt or she can fail and then complete, right? So this 0.72 will be simply multiplied with this particular attempts on how she can complete the game. Okay, so it's going to be, let's say, 0.6. If she completes 0.6, uh, she can go ahead and do 0.4. So first way to complete the game will be 0.6 into 0.4. So level 1 complete, level 2 complete. After that, the second way is level 1 is complete in the first attempt, but in the level 2, she failed and then completes the level 2. So that is the second way to finish the game. What is the third way? Fail, complete, complete, or fail, complete, fail, complete. Right? These are the basic ways through which Janice can complete her game. So if you just compute these probabilities, you will be done. Okay, that is how you can do part B. Moving on to the third question. So Hannah buys 12 hollow eggs or hollow chocolate eggs that each contain a sweet. The egg look identical, but Hannah knows that 3 contains a red sweet. There are 3 red sweet. I'll just keep on writing this in the proper way. 3 red and then 4 orange and 5 yellow. 5 plus 4 is 9, 10, 11, 12. So yeah, we are having 12 total of chocolate eggs. Each of Hannah's 3 children, in turn, randomly chooses and eats one of the eggs, keeping the sweet it contained. Of course, so 3 children are there, they are randomly going to pick these eggs and they're going to eat that particular thing, right? I hope that is the question. Yes. Find the probability that at least one of Hannah's three children chooses an egg that contains an orange sweet. So what do we exactly mean by the last line? Okay. First of all, the first paragraph contains the information that we are having total of 12 eggs, out of which 3 of them are having red sweet, 4 of them are having orange sweet, and 5 of them are having yellow sweet. Now, coming to the second paragraph or the last line, we are supposed to find the probability that at least one of these three children chooses an egg that contains an orange sweet. So let's say this is child 1, child 2, child 3. So at least one orange sweet should be there, okay? I'll use orange and not orange. Let's say if C1 had orange, C2 also had orange, C3 won't have orange, okay? And maybe this does not have this and this has. So over here, what we are trying to do is, we are trying to calculate the probability that at least one of these three children will have orange sweet. So a longer approach would be to find out how many total such possibilities are there, and there is nothing wrong with it. In the class today that we had in the evening, I had already mentioned that in statistics, there are multiple ways through which you can solve one question. Some techniques are very easy. If it comes in your brain, that's really good. If it does not come, you can always follow the longer approach. Over here, the doubt was that she was not really able to understand how to do this question. I guess Madhu had asked this question. So I'll tell you what is the best approach in my case if I look at this particular question. So because we are trying to look for at least one orange sweet out of the three children, what I can do is I can first find out what is the probability that none of them chooses an orange sweet. Okay, child 1 does not choose an orange, child 2 does not choose an orange, child 3 also does not choose an orange. Okay, so if none of them are choosing the orange sweet, and then if I do 100% minus this, it means that at least one of the children will have the orange sweet. That is the probability that we'll be finding. Let's say if this is the difficult way to understand this concept, and if you're good at doing the binomial distribution, then you can also think about this as, let's say, x is a random variable such that it's the number of orange sweets. Number of orange sweets chosen by the children, right? And then you're supposed to find that it should be greater than equal to 1. Okay, and the maximum number, of course, is 3. You are having 3 choices in total, right? At once, when you are selecting this kind of orange, orange, not orange, and all these kind of possibilities. So you know that with the help of binomial distribution, this is same as writing 1 minus probability of x less than 1. Okay, this rule is coming from the binomial distribution, where we know that on the number line we can plot 0, 1, 2, 3 up till the maximum value of n. Okay, so if I'm trying to find this probability, this is same as doing all of the probability and less than 1. If I do this, if I take away this much, I'll be left with exactly what we are supposed to find. So I hope that either this method or the first method that I talked about is pretty clear to you. So now what I'm going to do is, this was just the explanation for you guys. But yeah, now that I've realized that what I'm supposed to do, I'll just go ahead and say that probability of at least one orange sweet chosen. So it will be 1 minus probability of no orange sweets chosen. Okay, less than 1 means equal to 0, right? So 1 minus, so in total there are 4 orange sweets out of 12. So of course there are 8 other sweets. So 3 plus 5 is of course 8. Okay, so Uh, okay, so I'll say that out of 12, I am having 8 possibilities to choose any of the other sweets other than orange. And once I have chosen, let's say, one of the yellow, then I'm remaining with 7 other sweets. And of course, out of 12, I have consumed one. So I'm left with only 11 total eggs, out of which I'm having 7 possibilities to choose the other sweets and not orange. Similarly, now from the remaining 10 eggs, I am having 6 possible choices. And now if I do the mathematics with the help of my calculator, 1 minus bracket on the top I am having 876, and in the bottom I am having 12, 11, 10. And the answer that I'm getting is 41 over 55, or 0.74545 recurring. So that will be my answer over here. I can write my exact answer 41 by 55, even that is fine. So that's how you do this particular question. I hope you guys are able to understand whatever I'm explaining. In case of any kind of questions, please feel free to pause the video, go back, try to rewatch it, and after rewatching it, again, if you're having a doubt that I did not understand this part, you can always text me on the WhatsApp group and I'll be there to reply to all of your questions. And now let's move on to the next question. Question 4. A security code consists of 2 letters followed by 4-digit number. And here is one of the example of the code. The letters are supposed to be chosen from 5 of these, and the digits are to be chosen from 7 of these. No letter or digit may appear more than once. A security code is formed at random. You have to find the probability that the code is DE followed by a number that is in between 4500 and 5000, that is 4500 to 5000. So now over here the first confusion, is this question from the probability or PNC or both? So this question is only about permutations and combinations. Okay, mainly from the permutations, because we know that in the permutations we use it when the order matters. Over here the order matters because of course BE 3216 is not same as writing EB 3216. If this kind of order would not have mattered, you could have also used combinations over there, because combinations is just talking about how many ways you can choose BE combination. Okay, it does not take care about the permutations, that is the arrangements. So yeah, order does matter over here whenever you are trying to form a code, and that is why we are going to use permutations prominently in this particular question. So your question is, why is the word probability written over here? So as I mentioned, the probability is simply the basic thing that is you studied in your IGCSE also. That probability of any event to occur, what is the probability for, let's say, this kind of a code formation, that DE comes first followed by whatever kind of thing, over total possibility of forming these codes. So that is your basic understanding of probability. But how are you going to find the numerator and the denominator? That is with the help of permutations and combinations. Okay, so although I've asked you to keep this chapter at the end, but of course you are giving certain kind of trial and error. So of course this is one of the doubt that you will face in permutations and combinations. Okay, most of your doubts will be coming from permutations and combinations only. Even before your examinations, the only chapter that you will be worrying about will be this chapter only. There is no other way to, like, master this topic other than just keep on practicing it. It is just like functions, as I mentioned in the evening class. Okay, so a quick summary: we are having to choose 2 letters out of this 5, and we are supposed to choose 4 digits out of the 7, and a code is formed such that DE is fixed. Okay, DE is fixed, and after that we have to choose a number that is in between 4500 and 5000. So how are we supposed to do this? Let's go ahead and give you an idea. So DE is fixed, And now I am having 1, 2, 3, 4. So on the thousandth place, I need to start with 4. Okay. And then on my 100th place, I can have 3 different possibilities. Out of this 7, I can have 3 different possibilities. I can either have 5, 6, or 7. I can't have anything less than that because, of course, if I choose anything less than that, I will have a number that is less than 4500. I don't want that. So on the thousandth place, 4 is fixed. We know that because, of course, in between 4500 and 5000, 4 is the only number that will come over here. Okay, and we want the number that is in between. And because they have not mentioned exclusive or inclusive, by default we consider it to be exclusive. Of course, you can't really even form 5000 out of this number because, of course, repetition is not allowed now, and there are no zeros as such. So of course 5 is not possible to come over here. So on the thousandth place, we know that there is only one possible way to get the number, that is 4, right? And then in the 100th place, we can have either 5, 6, or 7. So there are 3 possible ways over here, right? There are 3 possibilities. Now, let's say we have chosen either of the 5, 6, or 7. Okay, I am just writing this, that either 5, 6, or 7. Whatever you have chosen, whatever you have chosen. Now, out of 7 digits, you are eliminating 2 digits, 4 and one of the 5, 6, 7. Now, how many digits you are remaining with? So let's say 4 is cancelled, and let's say 5 is also cancelled. Of course, 6 or 7 could have been cancelled, but just taking an example. How many digits are left in total now? 1, 2, 3, 4, 5. There are 5 digits that are uh, there. So out of the 5, I can choose any of them over here. So for this particular place, the 10th place, I can have 5 possibilities. And of course, after exhausting that, I'll only have 4 possibilities for the final dash over here on the unit place basically. Okay, what I'm doing basically over here is a part of permutations only. But I'm not really talking about permutations in terms of, like, the notations of the permutations. I'm just talking about the pure understanding of the permutations. Okay, so over here, to find a code or to find total number of code such that it starts with DE and the numbers stays in between 4500 and 5000, what are the total possible ways to have this? 3 into 5 into 4, right? So I'll say that the probability of code starting with DE followed by number between 4500 and 5000 is 3 into 4. I'll just do one thing. I'll call this an event X. Let X equal to this. Okay. And now I can say probability of X will be, what are the favorable outcomes? The favorable outcomes are 3 into 5 into 4. Out of how many total possibilities? So if I scroll above, we are having 5 letters, and from the 5 letters we have to choose 2 letters for the first 2 part of the code, and for the remaining part, out of 7 digits we have to choose 4. So please remember, this is the case of permutations because the order does matter over here. So I will say that I have to permute over here 5p2 and over here 7p4. and because both of the things are happening at the same time, so we're going to multiply. So in the denominator, the total outcomes will be 5p2 from this side multiplied by 7p4 for the code part, I mean the digits part. So yeah, if I substitute this into my calc and get my answer, of course you can't see my calc, but I am doing it in the same way that I've written right now on the board. So the answer that I'm going to get is 1 over 280. So a quick recap for this question. We are supposed to find the probability that the code starts with DE and then the remaining digits after DE will be in between 4500 and 5000. So for this, of course, D is fixed, so we don't have to think about it. So for the favorable outcomes or the possible outcomes for this particular event, in the 1000th place, of course, only 4 could have come. In the 100th place, either of 5, 6, 7 could come because we want the number to be greater than 500. So yeah, there are 3 possibilities for this 100th position. Then for the 10th position, if we eliminate 4 and one of the 5, 6, 7, you will be left with 5 different possibilities. So yeah, in the 10th position, you can choose 5 possibilities. And for the unit position, of course, after choosing one more number, you will be left with only 4 possibilities. So yeah, you're going to multiply all of these possibilities for the favorable outcomes. And then the total outcomes is how many ways in total you can form the code. It could be any code. So yeah, you are going to choose any of the 2 letters such that the order matters. That is why you're doing 5p2 for the letters and 7p4 for the numbers or the digits. And finally, you will be ending up with this particular answer. Now I know that this kind of question, the main thing that you will have to realize is that the confusion was that if this question is from the permutations, combinations, or the probability. So clearly you can say that this is the case of permutations, right? And probability is just a word in which we are applying the formula favorable outcomes over the total outcomes. That is the formula that we have learned in IGCSE, and we have been implementing this in almost all the kind of concepts of distributions as well, right? But in the distributions, directly you don't apply this formula. You divide it in multiple different ways, right? Like how you can implement the formula of the geometric binomial in the normal distributions. So let's say that kind of things are a bit different, but underlying process is this exactly the same thing. So I hope that this question has also given you an idea of how you can go ahead and solve the probability question only, but the underlying concept could be either of the distributions or the permutations and combinations as well. So if I just have to give you an idea, probability can have only 3 types of questions. It could be from the possibility space diagrams. Let's say you are throwing a 2 die, and out of these 2 dice, you have to find what is the total such that it is greater than equal to 4. So you sum up all the values over here, you get total of 36 different possibilities, and just find that out of these 36 different possibilities, how many of them were having the digits or the summation greater than or equal to 4. So yeah, that number over the total 36 will be a probability. The second type of question that we have just done, that is the tree diagram. And the last type of question is with respect to the distribution table. So only these 3 kind of questions is directly from the probability chapter. Now, if you're getting a question to find the probability using the permutations and combinations, or maybe from the distributions, so of course, this is the main thing that is getting tested, and probability is just the word that is given on top of this just to implement the favorable outcomes over the total outcomes formula. That's it. Okay. So yeah, I hope that this is much clearer to you. And now it's time to move on to the next question. Hey, where is it? Okay. So the question states that 3 digits are selected at random from the 8 digits 1, 2, 2, 3, 4, 4, 4, 5. So we are going to select 3 digits from the given 8 digits, and then we have to find the probability that the 3 digits are all different. Let's say, for example, 1, 2, 3, 2, 3, 4, 4, 5, 2, etc. etc. So all of these numbers should be different from each other. Now, one thing if you realize, this question is again not from the probability. This question is from the permutations and combinations only. And more specifically, this is from the combinations. Why? Because over here, the order of the digits that you will be choosing from the 8 digits won't matter. Over here, you're not trying to form a code in which the order matters, that if you don't follow the order, there will be a problem. Over here, there is no such problem. And because there is no such problem, we say that the order does not matter. And whenever the order does not matter, you can simply use combinations. Okay. So again, the question is not from the probability. The word probability is simply to say the favorable outcomes over the total outcomes formula. So we are supposed to find the favorable outcomes, that how we can find three digits that are different from each other out of the given 8 digits. So now this is a very classical question that we get in the combinations, where we try to create groups, a group of the same things. So there are two twos, and I'll just write two like this. And then there are three fours, and then whatever that is remaining is called as a separate group called as others. So I'll create another separate group and write 135 over here. Okay, and there are three such others over here for us. Now I have to form a digit such that all of them are different from each other. Okay, so I'll just try to create this kind of a pattern, or maybe I'll just try to create this kind of a group over here only, that I'm having two twos, then three fours, and three others, O for others, let's say. So for the first group, let's say I'm saying I am choosing 0 twos, 1 4. Of course, I cannot choose two fours because then how will it be different? Only 1 4. So from the remaining three, 1 3 5, I can choose two. Okay. So this will be like, out of the two, I'm choosing 0. Over here, out of the three, I'm choosing 1. And over here, out of the three, I'm choosing two others. So that is one possibility. What is the second possibility? That now one of the digit is from the 2, there is no 4, and because we want three digits, of course we can choose again some 3. Out of 3 we can choose two of this others digits, and then maybe let's say 2 and 4 both are included. If 2 and 4 both are included, so now we can choose only one from the others. And is there any other possibility? Yes, let's say if 2 and 4 both are not selected, and all three digits, because they are different, I can choose all three of them. Now I'll just need to make the combination equations and add all of these different possibilities to find the favorable outcomes, that we can form three digits and all of them are different from each other. So from the first one, I can say we are having 2C0 multiplied with 3C1, right? 3 from 3 fours I'm choosing 1, and then lastly from three others I'm choosing 2. And from here, similarly, I'll just simply do it very quickly. 2C1, 3C0, and 3C2. From here, from 2 twos, I'm choosing 1, and then from 3 fours, choosing 1, from 3 others, choosing 1, and lastly, none from twos, none from fours. From others, I'm choosing all of them, 3C3. Now, being pretty strong at the binomial theorem from P1, you should be aware about that NC0 is equal to 1, NC1 is equals to n, NCn is equals to 1, NCn minus 1 is equals to n. So these are the kind of things that I'm assuming that you're good with. Even if you're not good with, you can directly use calculator and substitute all of this. But yeah, I'm good with this kind of things that I've written, so I can do it very easily using my calculator, or maybe using my brain also. This is same as writing 1, 3, 3. This is same as writing 2, 1, 3. This is 2, 3, 2, 3, 3. And this is 1, 1, 1. So yeah, I can add all of this together in my calci and see what do I get. As usual, you won't be able to see my calculator, but I'll be doing the things. So first of all, 1 into 3 into 3. 3c1 is also 3, 3c2 is also 3. Then plus 2 into 1 into 3. Then plus 2 into 3 into 3. And lastly, 1 into 1 into 1. So that comes out to be total of 34 favorable outcomes. So I can just say that favorable outcomes or total is equals to 34. Now, out of how many total possibilities? Remember, we are doing combinations because the order of choosing these 3 digits does not matter. And that's why, because we are having total of 8 digits from which we are trying to form a 3-digit number, we can say 8c3 is the total possibilities. And therefore, final probability calculation, probability of choosing final probability that 3 digits selected, selecting 3 digits, 3 different digits is going to be equal to 34 over 8c3. So if I do, where is my calculator? Where is my calculator? Okay. So if I do 34 over 8c3, I'm getting 17 over 28. And this becomes my final answer. So I hope that you are able to understand that whenever they are giving the word probability, that does not really mean that this is from the probability chapter. You need to understand that it could be from permutations and combinations and also from the distribution. And how do you identify? Of course, you should be aware about this techniques that I had mentioned for the probability. And if it's not from these 3 techniques, of course, this has to be either from the distributions or from the permutations and the combinations. Okay. So yeah, I hope that this question is also giving you some idea of how to use the permutations and combinations to solve the probability question over here like this. Moving on to the next one, question number 6. Here we are given a game for 2 players which is played using a fair 4-sided dice. Fair means that the chances of every number is equal to come. So the probability in this case for all the numbers will be 1 by 4, 1 by 4, 1 by 4. Just like a fair 6-sided dice, right? It's the same thing, but now we are just having 4 numbers because it's a 4-sided dice. One turn consists of throwing the dice repeatedly up to maximum of 3 times. So in one turn, you can have maximum of 3 attempts. So the number of trials is equal to 3 in one turn. Okay. When a 4 is obtained, no further throws are made during that turn. So when a 4 will be obtained in these 3 attempts, in any of these 3 attempts, no further throws will be made. So let's say out of the 3 attempts, if I threw 4 in the first attempt only, the other 2 attempts will not be made. A player who obtains a 4 in their turns scores 1 point. A player who obtains a 4 in their turn. So if they are able to score a 4 in any of these 3 attempts, for that turn, they will be scoring a point. So now the way that I'm reading the question and I'm explaining it to myself only. This is exactly what you guys are going to do when you read the question, and after reading the question, you explain the question to yourself and also to the other 2 people in your group. Okay, so it's a very mandatory thing that you're not simply going to read the lines and then think about the solution. No, after reading the question, explain what it actually means. Okay, so just to summarize what is given to us over here, we are having a dice which is a 4-sided fair dice of the numbers 1, 2, 3, 4. There will be a turn that is going to consist of 3 attempts, and you're going to score 1 point from a turn if you are able to score 4 in any of the 3 attempts. If you don't score a 4, it means you are going to score a 0 point. Now, given this, the main doubt for Padmaja and Mithun was in part C, but to do part C, it is important that we should also be aware about part A. So in part A, there was no such problem. The probability that a player obtains a 4 in one turn is 37 by 64. That is what you're supposed to show. And I guess both of you have done it pretty well. But just for the sake of understanding what we are supposed to do, in the first and only, what is the way through which you can score a 4? Maybe in the first attempt only I got a 4, or maybe in the second attempt. So in the first attempt I didn't get a 4, but in the second I got a 4. And in the third attempt I'll get a 4. So in the first two I didn't get a 4, right? So that is a way through which you can say that in one turn only, in one turn we are having 3 different attempts, right? So in 3 different attempts, what is a way through which you can score a 4? Maybe in the first attempt only you got 4, maybe in the second attempt you got a 4, or maybe in the third attempt. Now you can find the probabilities. So this will be 1 by 4 plus 3 by 4 into 1 by 4 plus 3 by 4 square into 1 by 4, and that should give you 37 by 64. So I hope the first part is clear. Moving on to the second part was not related to the third part, so I have not included that. So in the C part, Xeno and Yao, anyway, X and Y each have 3 turns. So X has 3 turns, Y also has 3 turns. We have to find the probability that X scores 2 more points than Y. Okay, so X scores 2 more points than Y. And how to score a point? You get 1 point if you get a 4 in one of the turn, and both of them are having 3 turns. So let's say if Y doesn't score anything, then how can X score 2 more than 0? Of course, out of the 3 turns, X scores in 2 of the turns. Then let's say Y gets 1 point. So of course, for X to have 2 more points than Y, X must score in all 3 of the turns. So that is the kind of an idea. Now let's say if I say Y scores 2, okay? So over here I can't have 2 plus 2 4 because maximum turns are 3 only. So I cannot score beyond 3. So this is where I know I should stop. Okay. So I am having my X who is going to take 3 turns. Okay. So these are the number of trials. And in this 3 turns, probability of obtaining a 4 in one of the turn is 37 by 64. And same implements also for a Y. Y is another player who is again getting exactly the same number of turns, and in each turn even Y can score 37 by 64 probability. So what I'm going to do is I'm going to utilize the concept of binomial distribution to solve this question. So again, you can see that this question is not directly implementing the possibility space diagram or the tree diagram or the the probability distribution table. This is now connecting the probability with distributions. Okay. The previous 2 questions were from the permutations combinations, and this one is from the distribution, specifically binomial. But how are you going to implement the binomial? Over here, your game of binomial should be pretty strong. Over here, what I'm doing is, let's say I am going to summarize part C. Of course, I'll just leave some space for A, or maybe I'll just do part A over here only when I send this kind of solutions to you. So I'll just do C over here right away. So to find the probability that Zeno scores 2 more points than Yao, I'll just say that there is a variable X, which is for Xeno only. So Xeno scores a point. Okay, that is for X, that is one event now. And let Y also be another event where Yao scores a point. So I can easily say that my x belongs to a binomial distribution where the total number of trials for x to score a point are 3, and in each trial the probability to get a point is 37 over 64. And for y, I can say that y belongs to the binomial distribution with exactly the same criteria. Alright. Now, to find the probability that Zeno scores 2 more points than Yao, I have, when x is 2, y has to be 0. So I have to find what is the probability of x is equal to 2 and y is equal to 0, or the other way in which Xeno can score 2 more than Yao is the probability of x is equal to 3 and at the same time y is equal to 1. Okay, so both the things I'll have to multiply because I'm using and as the keyword. Okay, I'm not saying that x scored 3 or y scored 1. No, x scored 3 and at the same time y scored 1. That is when I can say that Xeno is scoring 2 more points than Yao, right? So that is why the multiplications of the probability will be coming into the picture. So you will have to implement the binomial for this and this plus the binomial for this and this. So let's go ahead and try to implement this. So I am having the probability of x scoring 2 more points. Then yeah, that will be equal to probability of x is equals to 2 and y is equal to 0, or probability of x is equal to 3 and y is equal to 0, or y is equal to 1. Yeah, all right. So over here, I'll just use this as the probability of success, and of course q will be the probability of failure. Okay, to just save my space, or else if I try to write it, it will be very complicated to fit in just one line. So what will be the binomial output if n is equal to 3 and x is equal to 2? It will be 3c2 times p to the power of 2 times q to the power of 1, right? For x is equal to 2, that is how it's going to look like. I'll use two different colors so that you can understand what I'm exactly doing over here. Okay, so 3c2 multiplied by p to the power of r, which is 2 in this case, and of course 3 minus 2 is 1, so the probability of failure, which is 1 minus this value, it will have a power of 1, which is then multiplied, it is then multiplied with the binomial of y is equal to 0. So now you are having 3c0. Okay, the total value of n is 3 and r is 0. So now 3c0 multiplied by p to the power of 0 times q to the power of course 3 minus 0 is 3. Now either this, or now when x is equal to 3 and n is equal to 3, it will be 3c3. 3c3 times p to the power of 3 times q to the power of 3 minus 3 is 0. And for y is equal to 1, it will be multiplied with 3c1 into p to the power of 1 into q to the power of 3 minus 1 is 2. Okay, so this is the simplification that we are able to get. Okay, so if I simplify this, of course 3c0 and 3c3 both are equal to 1. So I can simply say that this is equal to 3c2 is 3. Okay, so 3 times p square and then q to the power of 4 plus 3c3 is 1, 3c1 is 3. So again you are having 3, then p to the power of 4 and q to the power of 2. So yeah, this is the final formula. I know that for a 3 marker, you may find that this is very complicated, but no, this is not really that complicated. If you're able to think it directly, you could have directly got into this step in just 2 minutes of thought process. Okay, but yeah, giving that 2 minutes to yourself to realize that, okay, yeah, I can do this question. That 2 minutes of confidence on yourself that if I just keep on thinking, I will be able to hit something. That confidence will always be there once you are in a disciplined way practicing all these kind of things in the way that I've given you the task for P1. Okay, so once P1 will be completed, similar things you'll be doing for your S1 as well. Okay, so if I just plug in my details over here, I'm going to get, let me use same color. So this will be 3 times 37 by 64 square, and if I do 1 minus this, let's see what is the value. 1 minus 37 over 64 comes out to be 27 over 64. 27 over 64 to the power of 4 plus 3 times 37 over 64 to the power of 4 times 27 over 64 to the power of 2. Okay? The main thing that you had to pay attention over here is that, yeah, when x is 2, y has to be 0. When x is 3, y has to be 0. Now you just have to think about how to calculate this formula and this formula and multiply it. It could be maybe with the help of the distribution, or maybe just by thinking in the normal way of, like, how you think without the distributions. Even that would have been giving you the same result. But according to me, this was the easiest method. So I have implemented this. And the final solution that I'll be getting, if I put this into my calci, 3 into 37 by 64 square multiplied by 27 over 64 to the power of 4, and that answer, if I add with 3 into 37 over 64 to the power of 4, and then if I multiplied that with 27 over 64 to the power of 2. So this will give me the value as 0.0914. So this becomes your answer to this part. Once again, trust me, the binomial distribution, normal distribution, permutations and combinations is not that difficult. It just requires certain level of practice. Just solve the worksheets that I give you, and I guess you will be pretty much sorted after that. Of course, this kind of questions are once in a blue moon, okay, where you have to implement binomial like this. But yeah, now that you are aware about it, I hope that you will be able to keep this kind of things in your brain, that something like this is also possible. So the next time if you find this kind of a thing, and if you think that the binomial can be implemented, why not give it a shot, right? So yeah, that was about question number 6 over here for us. Moving on to question 7. Here we are given that Alicia has 4 coins. One of these coins is biased so that the probability of obtaining a head is 0.6, and the remaining 3 coins are fair. So Alicia has 4 coins, and from the 4 coin, 1 coin is biased such that the probability of head is 0.6. So of course, the biased tail will be 0.4. And for the other 3 coins, because they are fair, so the probability of the head and tail both are is equal to 0.5. Now, Alicia is going to throw 4 coins at the same time. The random x variable, or the random variable x, denotes the number of times the head is obtained. We have to complete the following probability distribution table for x. The doubt over here was coming from Madhu, that she was not able to get the correct value of the probability of x is equals to 2. The problem is, whenever we are given this kind of a table, they give you this kind of an example once once you will have to go ahead and test if whatever kind of logic that you're going to implement is even logical or not. Because let's say, for example, if you try to calculate probability of x is equal to 1, and if you're not able to get 0.2 to 5 only by yourself, it means that the logic that you are thinking about is having a problem. So I will recommend you over here, you can pause the video and try to get a 0.225 by yourself. And you will realize that yes, you are not able to get this because your concept of applying the probability is not correct over here. So over here, let me tell you, first of all, how to check if this is correct. Okay. So let's say if I'm saying that probability of 0 means only tails are there and one of the tail is biased. Okay, so it will be 0.5 cube into 0.4, that will give me 0.00, I mean 0.05. Similarly, if x is equals to 4, it means all of them are head. So one of them is biased, the other three are fair. So 0.5 cube into 0.6 will give me 0.075. So it's a very simple thing. But then if I talk about the probability of getting 1, then how am I supposed to calculate this? So over here, because we are having 4 coins, let's say the first coin that I'm having is a biased one. And after this, if the first one is head, of course, the remaining one has to be tail. That is one approach. The other approach is slightly like, not this straightforward. If you get a tail in the first attempt, okay, which is a biased, then you can get a head, then maybe two tails. Or after you got a tail, you again got a tail, then you got a head, then you got a tail. Or else you got tail, tail, then tail, and then head. So basically, there are total of 3 different routes if the tail is something that you are choosing first. For the head, there is one straight approach because if obviously the first one is head, nowhere else in the entire thing you can choose head. But whenever you are having a tail, in this case, you will be able to see that tails are having multiple approaches, basically 3 approach, right? This is my first one, this is my second one, and this is my third one. Let me show it to you a bit clearly. This is my first approach for the tail, this is my second approach for the tail, and this is my third approach for the tail. Okay, so yeah, basically what I'm supposed to do is whenever I'll be calculating tail first, where the tail is biased in short, in that case I'll have to multiply that probability with 3 because of course the values over here are all 0.5, so it's not going to harm our calculations. So this is the fundamentals that I'm able to think just by looking at this kind of information. Okay, so in that case, if I'm trying to implement this for probability of 1 only, x is equal to 1. So let's say HB and 3 fair tail plus 3 times tail biased and then 1 head and 2 fair tails. This is the kind of a thing. So this probability will be biased head is 0.6 multiplied with the 3 fair 0.5 cube, and over here of course 3 times the biased tail is 0.4, the normal head is 0.5, and these two are also 0.5, so again 0.5 cube. So now if I plug these values in my calculator, 0.6 into 0.5 cube, and then if I do plus 3 times 0.4 into 0.5 cube and then press equal to, yes, I am getting 0.225. So that is how you can confirm that your logic is now correct. If let's say I did not get 0.225, I would know that whatever I am thinking is not logical, right? So based on that, now I will not go ahead and find the probability of x is equal to 2 because you can see that it becomes very creepy as you go inside of the table. So instead of calculating the probability of 2, I will calculate the probability of 3. In this process, it's just that probability of x is equal to 3 means there are 3 heads and 1 tail. Okay, there are 3 heads and 1 tail. So now the only thing that is going to be shifted is you're going to multiply your 3 with the heads because of course heads will have multiple possibilities. If the first one is head, the second one could be tail, 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 right? Then let's say the first one was head. Sorry, my bad. I should have said because I want to have 3 heads, right? I want to have 3 heads. So first one could be head, second one could be head, third one could be head, and the fourth one could be tail, or head, tail, head, head, or head, tail, uh, head, tail, or head, head, tail, head. You can see that there are three different routes for the heads, and of course for the tail, if it's chosen first, uh, there is only one way to choose heads, heads, heads together. Okay, I can choose any another tail. So for the tail, there is only one approach, but now for the head, there are three approaches. So based on this concept, the way this will be calculated is three times the probability of this and one times the probability of this. Okay, so I hope I'm not confusing you guys. And let's try to do this over here once again so that you are understanding it. In the examination, I would have just used my calci and shifted the position of 3. That's it. But yeah, over here, because I'm trying to show it to you. So 3 times biased head and 2 fair head with 1 fair tail, or tail that is biased and 3 heads. So in this case, if I take my calci, so 3 times 0.6 into 0.5 cube, and that answer plus 0.4 times 0.5 cube, this comes out to be 0.275. So this is 0.275. Now, using the probability distribution table theorem, the summation of all of these probabilities should add up to 1. So of course now you can find the probability of 2 as 1 minus summation of all these probabilities. And the final value that you will be getting over here will be coming out as 0.375. If you do 1 minus all of this, you will get 0.375. So I hope even question 7 has made sense to you. Trust me, my explanations are very detailed because I have not taught you this kind of topics and still you are having doubts. So I guess this is the best way to explain. From the scratch, I'm explaining the concept and then I'm showing you the implementation as well. But now that, let's say, if you are aware about this kind of concepts, implementing them wouldn't be that much difficult. Okay. But yeah, that is how you're supposed to do this question. Moving on to the last question of this worksheet. So, W is a member of the same soccer club. He is also practicing scoring goals. The probability that the W will score a goal on any attempt is 0.6, independently of all the other attempts. So this is a very important thing that we should be aware about. It could be from the binomial distribution or the geometric distribution. W is going to keep making attempts until he scores 3 goals. So now because the number of trials are not fixed, this is your geometric distribution. So yeah, find the probability that he scores third goal in his 7 attempts. I'll just read it the question very quickly. So it's already more than an hour that I'm just continuously speaking. So yeah, I'm a bit tired now. But anyways, uh, so W is a part of a soccer club where he is also practicing scoring goals. And on any attempt that he's going to score a goal is 0.6, that is the probability. And that is independent of all the others. That is how we say that it could be either the geometric or the binomial, because of course we don't have mean or the standard deviation. And that is why of course only two possibilities are there. And then because the number of trials are not fixed, that is why it is geometric. So until the 3 goals are scored, okay, we have to find the probability that he can score the third goal on his 7th attempt. So 1, 2, 3, 4, 5, 6, 7. So over here there is one goal, that is the third goal. Now there are 2 more goals. Okay, you can fit them anywhere out of this 1, 2, 3, 4, 5, 6. Out of the 6 possibilities, you could have fit the first goal over here, the second goal over here. It could be anywhere, right? It could be anywhere. regardless of its position. So you can use a combination over here. Okay, you can use a combination that out of 6, you will have to choose 2 places to score the first 2 goals. Okay, so I'm going to say 6C2 is just to place goal 1 and goal 2. It could be anywhere over there. Now the final probabilities. The probabilities for scoring the goal, there are 3 total goals. So 0.6 to the power of 3, and then of course 0.4 is the probability where he does not score a goal, which is 1, 2, 3, 4. Right? In the 4 places, he is not able to, in the 4 attempts, he is not able to score a goal. So if you take out your calci and do this, 6C2 multiplied by 0.6 to the power of 3 and into 0.4 to the power of 4, this is giving me some weird long answer, 1296 divided by 15625. So that becomes your final answer for this question. So I hope guys that you are able to understand my technique of how I've implemented this. And yeah, just like this, we have completed the entire worksheet. And I hope that I was able to solve all of the questions. And I must say that being a beginner, if you are having this level of doubts, it means that you are doing really good in your S1. Okay, you are really doing pretty good. This kind of questions are not that easy. It is really very difficult for the beginners. So congratulations that this is showing that yes, you are practicing in the correct direction. And with more practice, you will see that you are doing much better as compared to what you are doing right now. Okay. So wishing you all the very best. I'll see you in the next class. Bye bye.